All right, here we go. Week 11, lesson number 1. Oh, Lord, we are rocking and rolling, moving and grooving today. Got to tell you from the outset, today is going to be a little longer than usual lesson, but I try to make up for it with the second lesson of the week, which I hope will be shorter. Just in case you've ever been confused about first lesson of the week, second lesson. This course is typically 16 weeks long. Because it's that long, we give one lesson per week. Like this would be the lesson. I should say we give 1 week, 2 lessons in a week. This would be the first lesson, and then the second lesson would come later in the week. But in this course, because it's a half of a semester rather than a whole semester, only 8 weeks, we actually end up giving 2 weeks in every week. That said, I think the workload's been manageable, even at that pace. So let's get started. We will cover, I'll do this one as thoroughly as I can with time restraints in mind because I really don't want to spend too much of your time on this. Our agenda for the week: homework answers for sure, always the same, to do it, some review work. Then we segue from the similarity that we discussed last week in week number 10 toward right triangle trigonometry and understanding where this is coming from. And the reason it's so important to cover some trigonometry, which will lead into the law of sines and later the law of cosines, is because we're trying to apply this to real life situations and real world problems. I remember once, I have 2 sons, and my youngest son always liked math. He did very well with it. My older one was pretty good at it, but he hated it, despised it with a passion. And there was a time there where my older son was working construction, and he was doing roof lines on homes and putting in rafters and stuff like that. And one day he called me up from work and he goes, "Pop, I got to tell you, all of that stuff that I did at school, all of that trig course that I hated so much, I'm using it every single day as I'm doing roofing here. And if you think about it, there's a right triangle in the roof, any roof line of a house." So even he wound up doing it. So I think it's real important that we get into some applications with right triangle trig. Next week, we're going to really embark on a hard study of statistics. Okay, here we go. Here's your first day's homework answers. Yes, I know they're on Moodle, but in case you didn't go to that, we've got it here as well. You can just take a look, the deal with stop and start and contacting me if there's any issues. Okay, there's the second half of it. And here's today's do it. And unfortunately, I did not put an animation on the correct answer. So try not to look at that. Try to work your way through the problem. Then we'll go over it in my time, a few seconds, in your time when you're done with the problem. Okay. Now, the width times the length times width, is going to be the area. So W times 2W plus 11 works out to be 30. Distributing that W, I get 2W squared plus 11W minus 30 equals 0. Now, we did this complicated factoring earlier on, I should say, where we take the 2, the leading coefficient, multiply it by the end, do the factoring, and then divide the 2 back in. So you should know how to do that. If there's any issues, make sure you reach out to me because that kind of factoring will absolutely be on your final exam. 2W plus 15 times W minus 2 equals 0. Might also be on a quiz coming up. Maybe it's the guy on the left, 2W plus 15 is 0. Maybe it's the guy on the right. Now, the 2W plus 15 equals 0 is going to come out to negative 7.5 or negative 15 over 2. So you reject that negative root. The other one, W, works out to be 2. So the width is 2, and the length is 2 times 2, which is 4, plus 11, which is 15. And the perimeter then, which is what they want. Oh, what are they asking for? It says, what's the perimeter of the rectangle? That would be the 2 widths, which are 2 and 2, and the 2 lengths, which are 15 and 15. You add them all up, and you get 34. Okay. Now, factor the expression 12t to the 8th minus 75t to the 4th completely. And that completely is a really important word. It's code, if you don't remember, for 2 steps or more. It's almost always 2 steps. So first find the greatest common factor, and then factor what remains. Go ahead, stop and start time. Okay, so they share a 3t to the fourth in common, so I factor that out right away. That leaves me with 4t to the fourth minus 25, and this is a perfect difference of two perfect squares scenario. The square root of 4 is 2, square root of t to the fourth is t squared minus 25. So here's the common factor I pulled out, the greatest common factor, 3t to the fourth. And then I get 2t squared plus 5 and 2t squared minus 5. Just to distribute back to check, 2t squared times 2t squared is 4t to the fourth, what we were looking for, minus 10t squared plus 10t squared minus 25. The minus 10t squared and the plus 10t squared up to 0 t's, which is what we wanted. Okay. Which set of numbers could represent the lengths of the sides of an isosceles triangle? Go ahead, stop and start. All right, so the tricky part of this is, and they do this with tests and questions, if you notice choice 1 can be a triangle, 4, 5, and 7. No matter which two sides you add up, they're always greater than the third. And choices 2 and 3 cannot be triangles. They can both be isosceles, but 8 and 8 is not greater than 16. It equals 16. And 6 and 6 is not greater than 13. But the problem with choice 1 is it's not an isosceles triangle. It's a scalene triangle. Remember, scalene means no equal sides. But choice 4 with 5, 5, and 9 is isosceles with the two 5s, and any two sides add up to be greater than the third. All right, so now a little twist on quadratic work. We just did this problem two questions ago where we pulled out a greatest common factor. I think you need to pull out a greatest common factor on this one also and then solve the resulting quadratic afterward. Stop and start. Go ahead. Okay, so they share an x in common. This is an old solution. In this case, they share an x in common, and then you would get x plus 2 times x minus 1, so it's going to be 0, negative 2, and negative 1. Sorry, this was the answer to a slide that was there before. Sure hope I didn't do that on this one as well. For all values of x, for which the expressions are defined, express the quotient in simplest form. Don't forget to flip it. Go ahead. Okay, so I do my factoring, and thankfully I did change the solution box on this one. X squared minus 9 is x plus 3x minus 3. 2x is, or let's do the denominator here. They share an x in common, x times x minus 5. Don't forget to flip it here. They share a 2x in common, so I put that up top. And then in the bottom, an x plus 3x minus 4. And then you can see the slash marks every time that I simplified something. The x plus 3's cancel, the x minus 5's cancel, and the single x's cancel. So I'm left with 2 parentheses x minus 3, or 2x minus 6 if you prefer. They're both acceptable, over x minus 4. All right, so that's some review of the past. And because today is such a long lesson, I didn't want to, and it's also a pretty heavy teaching lesson, I didn't want to spend more time than that going over review questions. What we're going to do now is just get into or re-examine the parallel concepts and how it's two parallel lines cut by a transversal, and that gives us the rules or the properties of parallelograms. Things like opposite angles of a parallelogram are congruent, consecutive angles are supplementary. When it comes to quadrilaterals, which are four-sided figures, there are two branches. There's the parallelogram family. Do-do-do-do. 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 You can hear my hard drive going in the background. That was the reason for the temporary wheel of death. Now, non-parallelograms include trapezoids, isosceles trapezoid, and kites. We really, for this course's purpose, we don't study those. I also teach a Math 1250 course that's about geometry, and that we get into the non-parallelograms. But in the parallelogram family, we have Papa parallelogram, which you know we went over the other day, just discussed his properties, and the children, Rodney the rectangle, Rebecca the rhombus, and Squiggy the square. The rectangle has its special properties: 4 right angles, congruent diagonals. The rhombus has 4 equal sides. The diagonals bisect the vertices, and the diagonals are also perpendicular to each other. And a square has everything. So you want to make sure that you understand or know those properties. You can always take a photograph of them and put it on your phone because, as you know, these tests and quizzes are open book. So are the projects. So there's your parallelogram properties. You should have taken a picture the other day. If you did not, pause it now, take a picture. You can see that's what we mentioned last time about the parallel lines cut by a transversal, and the reason that these two angles here, because they're the interiors, consecutive interior, they have to add up to 180. Okay, a couple of parallelogram questions to review our parallelogram work. Go ahead. Okay, so whenever we name a parallelogram, it doesn't matter where we start, but once we begin going in a particular order, we have to keep going. So parallelogram cars, C-A-R-S. You can't go like C-A and then R down here. No, you have to continue around the parallelogram. So what that means is that C and A, they're going to be consecutive, which means they add up to 180. So 5x minus 20 plus 3x plus 32 is 180. Same side, same operation. Altogether, that's 8x plus 12 is 180. Subtracting the 12, 8x is 168. Dividing x is 21. Okay, here you go. Consecutive sides of a rhombus. You should know what they are. Okay, so the beginning part of this question should be pretty simple for you. The consecutive sides are always equal. So that means 3x minus 2 will equal x plus 14. 2x minus 2 is 14 plus 2, 2x is 16. Divided by 2, x is 8. And what will the perimeter be? Well, if I plug the 8 back in, 3 times 8 is 24, minus 6 is 18. Oh, we changed it to a 2. Oh, all right. So I changed this question a little. It's going to affect this part. 8 and 14 would make 22. That's what it should be. Times 4 would be 88. There is no choice that matches up with it. Okay, try this one. Quadrilateral CDEF is a rectangle. BD, BE, because it's a rectangle, remember the properties of those diagonals. What's the value of A? Okay, so we know that BD and BE are both halves of equal diagonals, so therefore they're equal. Solving, and I get A is 51, or 61, sorry, 61. All right. Oh, here's another one where I didn't hide it. So let's just fix it right now. Animations, up here, back to slideshow, play from current slide. Why did that happen? That should not have happened in any way, shape, or form. Well, I probably had it right before. This is definitely should not have happened. But you can do the question and then check your work against my work. Okay, so AE is x plus 2, but BD is 4x minus 16. And the thing is that AE is half of the diagonal, so I have to double that AE. So 2 times the x plus 2 is going to equal the whole of BD, which is 4x minus 16. And I solved that equation. It works out to be x is 10, but it wants the length of AC. So it's 2 times AE. AE is 10 plus 2, so that's 12. And if I double that, I get 24. Okay, try this one. So you can expect to see parallelogram questions on upcoming quizzes and perhaps some upcoming projects, final exam. You'll see them in all of those places. So being familiar with them is a great help. Rhombus ABCD, the diagonals are AD is 10 to one side, and then it says that AC is 12. But you have to remember that a rhombus is a parallelogram, so the diagonal bisects each other. So, and the diagonals are also perpendicular. So there's your perpendicular symbol. And because they bisect each other, each of those parts is 6. The whole thing is 12. The missing side, this piece here from D to the middle, we'll call X. But because this is a right angle here, this is a right triangle. And in a right triangle, one of the things we should know is the Pythagorean theorem. So leg squared plus leg squared is hypotenuse squared. 6 squared plus x squared is 10 squared. Works out to be that x is equal to 8. Now it wants the length of dB. That's the whole thing put together. That's an 8 and then another 8 for 16. All right, so that's a pretty thorough hashing back of parallelogram properties. Now our last lesson focused on similar figures, and that's going to lead to our trigonometry work today and in the next lesson. So little is to big as little is to big. Give it a shot. Go ahead. Okay, so what we have here is little is to big as little is to big. 6 over here, side, here's your little triangle, right? ADE, that's what the little refers to as little triangle. 6 is to the big triangle, ABC, that's 16. As the little triangle 9 is to the big length, which is x plus 9. Cross multiplying, 6 times x plus 9 equals 120? I don't think so. 9 times 16 is not 120. It's 144. So let me... Oh, all right. So the next line had it right anyway. Okay, so here it is, 144. The next line had it right anyway. So distributing 6x plus 54 is 144. Subtracting the 54, 6x is 90. Dividing, and I get x is 15. Now, some people might say, well, you know, I could have done that a different way, and you can. The problem is, whenever we start getting involved in these segments in like DE and BC, and we try that same approach, it always ends up wrong. So I like to go little is to big as little is to big. That always works 100% of the time. Okay, D and E are midpoints. BC is 34. Find the length of DE. It's my dog drinking water. So remember, when you connect midpoints, it forms a segment parallel to the third side, which is BC, and half as long. So it's 17. Give this one a shot. Okay. So little is to big is little is to big. 5 AT is to the whole length, which is 12, right? That's 5, this is 7. As 10 is to the whole length here, call that x. Cross multiplying, 5x equals 120, dividing by 5, x is 24, but it only wants VC. So for that, I have to subtract the 10 off. 24 minus 10 is 14. Choice 3. A little late for that. Okay, in the diagram below of triangle ABC, DE is a midsegment, which means it joins the midpoints of triangle ABC, the great big triangle there. DE is 7, AB is 10, BC is 13. Find the perimeter of the big triangle, triangle ABC. Go ahead. Well, remember, since D and E are midpoints, the 7 is going to be half of this side, which is 14. And then the perimeter here will be the 10, the 13, and the 14. So 14 plus 10 plus 13 is 37. All right, let's try this one. Measure of angle A is x plus 27. Measure of angle B is 4x minus 17. Measure of angle C, 5x minus 20. What kind of triangle do we have here? Go ahead. Okay, so x plus 27 plus the 5x minus 20 plus the 4x minus 17 is 180. That gives me 10x minus 10 is 180 when I do my same side, same operations here. Adding the 10, dividing by 10, and I get x is 19. So 19 and 27 make 46. 4 times 19 minus 7 is 59. 5 times 19 minus 20 is 75. It's scalene. All of the angles are different, which means all of the sides are different. All right. So we've done our similar figure work. We've hashed over all of the review. Similar triangles progressing to trigonometry. So there's two things mathematicians are. They are brilliant and they are lazy. So a mathematician's sitting around and he figures out, okay, I got this 30-degree angle here. And in the triangle, this side that's across from it or opposite it, this side is 10. And this long side here that's opposite or across from the right angle, that's called the hypotenuse, right? You should know that. And this is 20. And he said, well, wow, if it's when I have one side of 10, the opposite side, and a hypotenuse of 20, I measure that angle and I get exactly 30 degrees. Then they turn around and they cut everything in half so that this is 5 and that's 10. And they realize it's still 30 degrees. And they look at this ratio of the opposite to the hypotenuse, and it's always a half. It's always 10 over 20, 5 over 10. I can make a little tiny triangle in here, and that would be, say, 2 over 4. So that ratio never changes. And the mathematician said, well, how can I begin to use those ratios to help us out? And they did that. When the ratios stay the same, as long as the angle stays the same, mathematicians noticed this and realized they could apply that concept to real-world problems, which is what this course is about. But first, they needed to establish some terminology so that people would understand what they were talking about. And what they did was they came up with certain trigonometric ratios. Now, when you were in school, in public school, just about everybody learned of the functions that are in yellow: sine, cosine, and tangent. In fact, there's buttons for them on your calculator. Not everybody learned about cosecant, secant, and cotangent, and we'll talk more about that in a couple of minutes. The first thing I want you to focus on here is a right triangle. And this angle here, this is called theta. It's a Greek letter. And compared to the angle theta, the opposite side is the one that's across from it, far opposite it. Like if you and I were sitting at dinner and you were sitting across from me, we would say that we were opposite each other. But if you sat next to me, we would say we were adjacent, like your next door neighbor is your adjacent neighbor. Or when we did supplementary angles and we said that two angles that are next to each other, two adjacent angles that share a ray in common, together they make a straight line, so therefore they're supplementary and add up to 180. The hypotenuse is always across from the right angle. So opposite is across from the angle, adjacent is next to the angle. Here's theta, and the adjacent is next to that angle. Now the hypotenuse is also next to the angle, but the thing is the hypotenuse is the only side that's across from the right angle, so that's its priority in identifying it. And then the sine of that angle theta will be the length of the opposite over the hypotenuse. The cosine will be the adjacent over the hypotenuse, and the tangent will be the opposite over the adjacent. Those are the ones we learn a lot when we're younger and in school. And we have a little acronym to state what that is, and it's called SOHCAHTOA. It's old Indian chief. SOHCAHTOA means sine is opposite over hypotenuse. Here you go, ready? There's the S, sine, O opposite, H hypotenuse. Same thing here, O opposite, H hypotenuse. Cosine, adjacent over hypotenuse. So it's SOHCAHTOA. SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. We'll talk about secant, cosecant, and cotangent in a moment. Okay, so the first thing they want you to do here is find the sine of x, the cosine of x, and the tangent of x with those values thrown in there. So go ahead, do that. Find sine, cosine, tangent. And then we'll talk about the cotangent, the secant, and the cosecant. Okay, so remember SOHCAHTOA, I wrote it there. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent's opposite over adjacent. Boy, oh boy, if you can't spell, this is tricky. So the sine will be the 5/13. The cosine is the adjacent, which is 12, over the hypotenuse, which is 13. The tangent is the opposite over the adjacent, which is 5/12. Now, what do we do with this sine, cosine, tangent, and then cotangent, secant, cosecant? Well, first off, I want you to know that these functions are normally learned in this order: sine, cosine, tangent, cotangent, secant, cosecant. And we could go into a big study off of that, but that big study is not necessary to solve real world problems, so we're not going to go into that. Sine, cosine, tangent, cotangent, secant, cosecant. So do you see how we went sine, then cosine? Now we have tangent, then cotangent. The cotangent is the reciprocal of the tangent. So if the tangent is 5/12, the cotangent is 12/5. The secant is the reciprocal of the cosine. So if the cosine is 12/13, the secant is 13/12. And the cosecant is the reciprocal of the sine. If the sine is 5/13, the cosecant is 13/5. So I want you to, I really tried to emphasize the way I said the words before when I said sine, cosine, tangent, cotangent, secant, cosecant. And you can see them listed here, ready? Sine, then cosine, tangent, cotangent, secant, cosecant. That order is pretty much the order that everybody learns these in: sine, cosine, tangent, cotangent, secant, cosecant. And if you pair them up from the middle, you have your reciprocals. Tangent and cotangent are reciprocals, cosine and secant are reciprocals, and sine and cosecant are reciprocals. So just learn to write them in that order vertically: sine, cosine, tangent, cotangent, secant, cosecant, and then pair them up with brackets from the middle, and you have which ones are the reciprocals of which ones. So you really only need to remember the order you write them in, and then SOHCAHTOA. Because then if you need another one, you just flip them as, or take the reciprocal as needed. Okay, find sine of x, cosine x, tangent x, cotangent x, secant x, cosecant x. Go ahead. Okay, so what we have here, we start with the brackets. The sine of x is the opposite over the hypotenuse, which is, in this particular case, you know what? Oh my God. I left x here. You needed to solve for x, and that's through the Pythagorean theorem. And I do have that solution for you, but I didn't animate it first. I animated it last. So let me put these solutions in here, and I'll put all the answers up and all the pairings up. Here's the work to find x. Right triangle, I need a side, so I do Pythagorean theorem. Leg squared plus leg squared, or a squared plus b squared, equals c squared. Leg squared plus leg squared is hypotenuse squared. So 6 squared plus 8 squared is x squared. 36 and 64 are x squared. 100 is x squared, so x is 10. So x works out to be 10. So therefore the sine of x is 6 over 10, which is 3/5. The cosine is 8 over 10, adjacent over hypotenuse, right? Which is 4 over 5. Remember, SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So, again, cosine is adjacent next to the angle x, which is 8 over the hypotenuse, which is 10. And that reduces to 4/5. Tangent of x is the opposite over the adjacent, which is 6 over 8, which reduces to 3/4. And now to find the others, the cotangent, I just do the reciprocal of the tangent, 4/3. Secant reciprocal of cosine, which is 5/4. And cosecant reciprocal of sine, which is 5/3. Okay, let's use SOHCAHTOA to find sine of A, cosine of A, tangent of A, cotangent of A, secant of A, and cosecant of A. Go ahead, start time. Okay, so sine of A, opposite over hypotenuse. Now, A is way up here in the triangle. So the side that's across from or opposite of A is the 12. And the hypotenuse, that's always across from the right angle. That's 15. 12/15, which is 4/5. The cosine is the adjacent side next to the A. That's 9/15, which is 3/5. Tangent is the opposite over the adjacent, which is 12/9, or 4/3. The cosine, or the cotangent, I'm sorry, that's the reciprocal of the tangent because they pair up from the middle on out. Secant's reciprocal of cosine, 5/3. Cosecant's reciprocal of sine, 5/4. And there are your pairings right there, showing you what's the reciprocal of what. SOHCAHTOA again, this time, it's the same diagram, but instead of finding the sine, cosine, tangent, etc. of A, this time do it for C. Find the sine of C, the cosine of C, tangent of C, and so on and so forth. Go ahead. Okay, so the sine of A works out to be the opposite over the sine of C, is the opposite over the hypotenuse. Here's angle C. Opposite is 9, hypotenuse is 15, that's 3/5. Cosine is adjacent over hypotenuse. That's 12/15, or 4/5. Tangent is opposite over adjacent, which is 9 over 12, or 3/4. Cotangent, 3/4 becomes 4/3. Secant, 5/4, because it's the reciprocal of the cosine. Remember, you pair up from the middle. And the cosecant is 5/3. There's your pairing up from the middle. Okay, so let's take those concepts now and apply them to a single question about a single diagram. Go ahead, read this through. Let's see what you got. Okay. Now, compared to the 28, it wants to know, it gives you this information. You have ED is 15, angle C is 28. It says which one can be used to find CD. So let's talk about, I think the answer is choice 1. So let's take a look at choice 2. Is the sine of 28, now CD is the adjacent, okay? CD is the answer is not going to be choice 1. Sorry, I'll go back to do choice 1 in a minute. CD is the adjacent side. So compared to the 28, the 15 is the opposite and CD is adjacent. Sine doesn't have to do with opposite and adjacent. See, sine is opposite and hypotenuse. Here's another one. Sine is 15 over CD or CD over 15. As we discussed, the sine, there's no A there, has nothing to do with the adjacent. But the tangent will be the opposite over the adjacent. So the tangent of 15 over CD, that is opposite over adjacent. So we have choice 3. That's around choice 3. I don't know if you noticed that or not. We're going to drag that over there and go back to play from current slide. Okay. Come on now. Showing you how a trained professional handles an emergency situation. For some reason, this is dragging. There we go. Okay, so choice 3. Now, this one, similar idea. It says, what's the tangent of B? SOHCAHTOA. Remember what TOA TOA. What does that stand for? Go for it. So the tangent of B will be the opposite over the adjacent. Compared to angle B, the opposite's 12, the adjacent's 5. Choice 1, 12/5. Okay, so we can now identify sine, cosine, tangent based on SOHCAHTOA. We understand the reciprocal trig functions, which are cotangent, secant, cosecant. We just pair them up and flip upside down if I want to know them. How do I apply these to real-world problems? Now, look, this could be the top of a house, and that could be a roof like my son used to deal with. Or it could be like a telephone pole and a wire supporting the telephone pole, or it could be a ladder trying to get up to a particular point. There's many real-world examples that are indicated by this particular diagram of a right triangle. It's something that we see used constantly. Find x to the nearest tenth. And what I would like to do is have you try this, remembering whatever you can from your distant past about how to do these. And then I'll take you through it. We're going to go through a bunch of these. So don't worry if you don't get this one right. So looking at this diagram and compared to the 35-degree angle, I am dealing with the opposite side and the hypotenuse. Now, which of SOHCAHTOA, sine, cosine, or tangent, deals with the opposite and the hypotenuse? I'm looking for OH, opposite and hypotenuse. It's right here. So the sine of 35 will equal the opposite, which is 56, over the hypotenuse, which is x. Now, this is when you go to your handy-dandy calculator. And if you have a graphing calculator, which I do hope that you have by now, we have to look up the sine of 35. Please look at the sine of 35 on your calculator now, and let's make sure that it says 0.5736. So that sine button is in the middle. It's just above the apostrophe, which is 2 buttons above the 7. Okay, so hit sine, then hit 35, and make sure it says 0.5736. If it does not, then go to the second button and mode. Second mode. Okay. Oh, no, just hit the mode button. Sorry, just hit the mode button. And if you notice, the third one down says radians or degrees. Make sure that degrees is highlighted. That's very important, okay? All right, if once it's in degree mode and not radian mode, and you press sine 35, you will get 0.5736. Now, that'll equal 56 over x. Cross multiply. And remember, when we cross multiply, I multiply these two, and I get 0.5736x. And there's really a 1 underneath here. You don't bother to write it, but it's there. And 56 times 1 is just 56. I divide both sides by 0.5736. When I do 57 divided by 0.5736, I get 97.6. What is so important about this? Well, what's so important is that these ratios that we showed you before, remember we started with that triangle, the opposite was 10 and the hypotenuse was 20, and then we broke it down to 5 and 10, and we said it could have gone further to 2 and 4, etc. Based on the angle, the ratio never, ever, ever changes. So that means I can be missing a side of a triangle. And as long as I know that angle, I can find the side. Or if I knew the sides, I could find the angle. That's powerful because, like I said, if you're building a roof and you want to know how long a piece of lumber you need to put there, or if you're supporting a structure, like let's say you have a beautiful, you're the bride or the groom, it's the wedding day, the dream of the year, and they're putting up a tent outdoors in some, I don't know, vineyard or along a river somewhere, and it's your magic day. If they don't secure the tent right and the tent collapses all over the food and your guests, your event just became a horror show. So we have to make sure that we can measure these things correctly. That's what we did right here, okay? Also, when you're building a house, there's a moment when even the sides of the house are held up like this. So that's what we want to make sure that we can do. And trigonometry allows us to solve problems like that. Okay, give this one a try. like before, find x to the nearest tenth. The whole key is to look at that 15-degree angle and ask yourself, compared to the angle, what sides are being talked about or asked about in the diagram? Okay, so compared to this 15-degree angle, it's the opposite side and the hypotenuse. So the sine of 15 will equal the opposite x. Opposite and hypotenuse means sine, right? S-O-H, sine, opposite, hypotenuse. The sine of 15 will be x over 32. I look up the sine of 15 on my handy-dandy calculator. It tells me 0.2588 equals x over 32. I cross-multiply here. There's really a 1 under the 0.2588, and that gives me x equals 8.3. So again, key to it all is identifying the function. Is it sine, cosine, or tangent? And then putting the values, the x, the numbers, etc., in the proper places. Try this one. Hint, it's not sine this time. Okay, so in this particular problem, compared to this 86-degree angle, I still have the hypotenuse, right? The 72 is across from, 6 is just the problem number. 72 is across from the right angle. But this x here is the adjacent side to the angle. So the cosine this time, because adjacent and hypotenuse, cosine. So katoa. Cosine 86 is x over 72. I look up the cosine of 86 and I get 0.0697 equals x over 72. And then I cross multiply and I get x equals 5.0. Just word to the wise, never, ever, ever look at what you think the diagram says it should look like. Always go by the numbers, because it certainly looks longer than 5, but 5 is the correct answer, 5.0. Okay, try this guy. A little tricky here because they kind of tilted that triangle on you, but you can still see where the hypotenuse is, and you can still see the angle up top. It says find x. Well, what two sides do I have there compared to the x angle? I have the opposite and I have the adjacent. Opposite and adjacent. Now, find x. Opposite and adjacent. Now, how do I do this? Well, opposite and adjacent is tangent, so I know that much is true. Whenever I want to find the angle, I'm working backwards. So I use the sides to get the angle. And what I say is that the tangent of x must be 19/24. And whenever I want the angle, I put a little -1 up top there. That in function theory means inverse. So it means go backwards. It means I'll give you the value, you tell me the angle. And that's what we're doing here. If you go to your handy-dandy calculator, you'll notice that there's 3 buttons across there are 2 buttons above the 7, 8, and 9. One of them says tangent. But if you notice above where the button says tangent in blue, it says tangent -1. That's that tangent inverse notation. So what you're going to do on your calculator is you're going to hit the second button, which is also blue. So you hit second tan. And now that gets you the tangent inverse function. Second tan gives you what angle has a tangent of, in this case, 0.7912. And it'll tell you 38.4 degrees. So to find the angle, you always just hit the second button, then the function. What tells you to hit the second button? Tangent inverse right here when you want the x to be the angle. Okay, try this one. Go ahead. You know, it's funny, I put the 12 there because this worksheet that I got these questions from, it actually had a number that was impossible, which was really surprising. On one hand, because, you should know better. But on the other hand, I make careless mistakes pretty much on every PowerPoint. So I'm not surprised that they did either. Go ahead, find x in this particular diagram. SOHCAHTOA. So in this diagram, we have the adjacent and the hypotenuse. So it's not tangent inverse or sine inverse, it's cosine inverse, because the 12 is the adjacent side. It's right next to the x there. See it? The opposite's all the way over here. So I do second cosine, 12 divided by 16.7. That's second cosine of 0.7186. And that's 44.1 degrees. Let's do one more of these second functions. Try this one. Okay, again, I'm going to get adjacent and hypotenuse, so that's cosine. I want the angle, so it's cosine inverse or second cosine. Adjacent is 2.2. Hypotenuse, which always across from the right angle, is 3.1. So the second cosine is 0.7096, which gives you 44.8 degrees. All right, so here's a little bit of a real life problem. It's a little bit contrived because roads don't go straight, but we're still going to work with it. Consider it to be like how a bird would fly. Go ahead, read it and answer it. Okay, so compared to angle X, I have the opposite, which is 280, and the adjacent, which is 170, right? I don't have the hypotenuse because that's across from the right angle. So the tangent inverse of 280 over 170, second tan. So I do second tan of 1.6471, and that's 58.7 degrees. So that's the measure of the angle you need to connect it. Your happy recap for this lesson. SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Remember, of course, to list, I didn't write this here, but list those values: sine, cosine, tangent, cotangent, secant, cosecant. It's always the co afterwards. Sine, cosine, tangent, cotangent, secant, cosecant. Always list those afterwards. And then whenever you're going to find the angle, when that's what you're missing the angle, you're always going to do second or inverse to get that one. Okay? All right, that's our intro to trigonometry. The next lesson, we do a whole lot of solving trig problems in real life. We do a lot of laws of sine and cosine in the next lesson. All right, do all of the homework when it's due. That's a great way to succeed in class. We've been talking about it a lot. It's getting a little late, but if you haven't been, you can still salvage some of that extra credit like material. It's not exactly extra credit, but it's similar to. How you go about your business is so critical. If you've been going about your business the way we expect you to, I'm sure you're doing really well in class. If you have not been, boy, oh boy, it's getting late. I do not like failing students, but I will not pass a student who deserves to fail. And the way the class is structured, if you do your work, if you're responsible and on top of things, you're going to pass. Pay attention to due dates. They're all over Moodle. Make sure you make it happen. Work together on projects. Takes pride in your work. That's always a critical thing. That helps so many people succeed. If you have a great work ethic, you will always be successful in life. And finally, every day is a chance to realize your dream. You're either taking steps towards your dream or you're not. If you're doing whatever, a lot of college kids party their brains out. My son went fishing all the time, my oldest one. If you're not pursuing the work and having a good work ethic that you should have, it's going to reflect itself in your work. But if you are, the dream is going to become real, and one day you'll have a whole lot better life. Hopefully we still live in a world where they don't just make everybody's outcome equal, and your work ethic takes you to where you want to go. Have a great day.